Hey everyone, it's Mate from Scan&Eggs. Today I'm going to share a method I come up with to create non-tiling cell-based materials like this pavement or this brick wall here. I made a more complex material which you can download from our website for free. And also, if you're already there, please check out our plugin called Construction Editor Mode, which I use to create all these beautiful buildings here. Alright, let's dive in. Every procedural material should have good noise or random function. And today we will use hash without sign by Dave Hoskins. And in the common tab you can find the hash12 function, which has a vector2 input and a single float output. So I will implement this in Unreal Engine as a material function so we can reuse it later. So let's create a material function. Let's name it mf hash2 and let's start the implementation. We have a vector2 input, so let's drop down a function input, set it to vector2, and let's start with the first line. We have a vector3 p.xyx, so let's break the float 2 and let's create a float 3 and connect it as it says xyx, x, y, x. And after that multiply it with a constant 0.1031. And we take the fractional part of this. And this is the first line. So the second line, we take the y, z, x of this vector. So make float 3 and break float 3. And we take the y, z, x. And we add a constant 33.33, and we take the dot product of p3 and this value, and we add this, the result of this, to the original p. Alright, what's next? So we take the x and y value and add it together. So break float 3. We add the x and y. And we multiply it with z. And we return the fractional part. And that's it. So we can test it out by using a word position and masking the z value. And we can see that we have a noise. Great. Let's click somewhere empty and check expose to library and save. After that, if we right click somewhere in the material editor and type hash, you will see your newly created hash2 function. Let's talk a little bit about UVs. UVs are a coordinate system used for mapping 2D textures to meshes. In Unreal Engine, you can get the UV map of a mesh by dropping down a texture coordinate, and if you connect it to a texture sample, the image gets mapped to the mesh, right? So what happens if we multiply this by 3? So the UVs are not going from 0 to 1 now, but going from 0 to 3. You probably know this, but this will tile the texture 3 by 3 times. So what happens if for example, if we floor these numbers, we can visualize this kind of like this. So our UVs are going from 0 to 3, and our texture is repeating, right? If we floor these numbers, this cell will be 0 at U and 0 at V. And this cell is going to be 1 at U and 0, 2, 0. And downwards 0, 1, 0, 2. You get the idea. So we managed to create a unique flow2 for each cell. And before we made the hash2 function, which exactly needs a unique flow2 for input, so we will get a random number for each cell. So let's try that. So if I say hash2 and I start to preview this node and maybe increase the division, we can see that we have random gray cells here, right? So what can we do with these random gray values? I will show you 3 things. So first, let's make some random colors, for example, from this. We can drop down an HSV to RGB and the make float 4. And let's connect the random grayscale values to the H input, so X, hue. The saturation and value can be 1, 1. And the last digit can be 0. So for example, if we multiply this with our texture and we preview this multiplication mode, we will have this beautiful little random colored whatever, right? So this is great. What else can we do? We could offset the UVs. So we can use our grayscale value and add it to the UVs and feed that to the texture sample. So we are offsetting each cell by a random value. You can see that the offset is diagonal always. And this is because we are using the hash2 as a float2. So both float values are the same. So if you want to randomize it even further, you can either use 2 hash2 with a different seed, like this. So you can see that the offset is totally random right now. Or you can cheat a little bit and create another random number by multiplying this by 10 and saturate. So basically shifting the random number 1 digit. It's a bit cheaper. Or we could rotate the UVs as well. So we can use a custom rotator and feed the UVs inside and use our random number for the rotation angle. The rotation angle is between 0 and 1 and our random number is between 0 and 1. So let's see how that looks. Okay, it's cool, but it rotates around the 0 point. So we can fix that by flooring each cell and subtract from the UVs and feed that to the UV input of the custom rotator. So it will rotate around each midpoint of the cell. Or you can combine all of these together or come up with totally different other solutions. What if we have a texture which has random grayscale values inside? What can we do with these? So we've seen before that we have a unique ID for this cell, right? 0, 0. and we have these gray values. So we could add these together to generate another unique value for this cell, for example. So if the grayscale value is 0.5 here, then we will have a value here which is 0.5, 0.5, which is unique because the next one will be 1.5 and 0.5. So let's do this in Unreal Engine. We have our texture sample. I'm using absolute world coordinates for the UVs, just to make it easier for me. And we said that, okay, we need to floor the UV values and add these together, right? And put the hash to. Let's preview this. We can see that we have an error. It's because this value here is a float 2 and this one is a float 3, and we can't add those together. So let's use only the R channel because we can add together float 1 and a float 2. You can see that we have random values even inside our texture cell. So if you have a material which every cell ends inside the texture, then you're pretty much done. You can create infinite materials with total random variations, like this. But what happens if you have a texture like this, where the end of one inner cell continues to the neighboring cell, right? So if you would do the same, adding these together, so 1, 0 here, and this is, let's say, 0.8, then if we add these together, it's going to be 1.6, 0, and this one is going to be 2.6, 0, right? Which is not equal. So these two cells, two parts, will be different colors. So what can we do about these? We could create a position texture. These are from Substance Designer, and these are mapping the center position of each cell to a color, basically representing the position. So the problem with this is that this cell here continues here. So the center point is going to be 0. And this will have the same issue because these two values are the same, so it will generate another value here. So the hash 2 will give you another color. So we need something else. We need a position texture which is different at the border. And if we add these together, then we will have the same number. So for example here, if this value is 1 and this is 0, and this is the 1, 0 cell, and this is a 2, 0, and if we add these together, 1 plus 1 equals 2 plus 0, right? So we need a texture like this. In Substance Designer, you can create a position map by creating some kind of pattern, then detect the edges, and do a flat fill, and from the flat fill you can create a position map. But this is the wrong one, because one cell repeats itself at the other side. So how can we fix this? The same way we create our pattern, then we double its size, do our position mapping, and transform it back to the previous scale. So double its scale and then divide its scale. And with this, we are cutting the cases which were not good in the previous version, and we will handle the value change in Unreal Engine, because now it's not going from 0 to 1, it goes from 0.25 to 0.75. So let's use our newly created texture here and remap the values. As we've doubled the size in Substance Designer, we need to remap these values. So we multiply it by 2 and subtract 0.5 to remap it between 0 and 1, and add these together and feed it into the hash 2. Let's see the result. And we can see that it's not working at all. Right? So why is that? Let's open up our texture settings here. And let's change the compression settings to HDR high precision. If we check it again, we can see that it kind of works, but we have a lot of little lines here. So these values, which are fed into the hash 2, are very sensitive. So a little bit, like a 0.001 difference, is enough to generate a new random number, right? So let's round these up a little bit to make it easier. So I multiply the values by 100, round it there, and divide it back by 100. And it will make 2-digit values from it. So you can see that we are pretty good but if we go further away, there are some weird noisy lines between the cells. So let's go back to our texture. And we know that it automatically creates loads or mipmaps. So let's turn those off. So no mipmap. Now we can see that it's pretty clear if we are zooming back and forth, but there are still these lines between the cells. So we can fix that by searching for filter here and changing the default filter to nearest. Let's save that. We can see that we have a pretty nice little texture, which is huge in size because we are not compressing anything, basically. So I found that the best is BC7, which will make our texture from 4 megabytes to 256 kilobytes. So save that, and it still works. Great. So now we have everything ready to create infinite non-tiling textures. So I will show you one I made earlier. So let's start with the position texture. I created this one in Substance. It's just a basic brick tile. I remap the values, round it, and I create 2 random numbers. I really like these named reroutes. You can make one by typing named and add named reroute declaration node, and then you can use the same name to shortcut to that. So basically you can reorganize your whole graph like this. So I create 2 random numbers. One is the hash, the other one is the cheat. So just shift 1 digit and use it as a random, another random. And I have 3 textures here. One for the base color, another for the mask between the cells, so we hide the seams, and one for the details, for the shades. So this is kind of like an ambient occlusion map I will use for roughness and some other things. So let's start with the base color. I'm scaling it up a bit and I'm adding random offset to it. After that, I'm adding the details from the shade texture. I'm darkening it, so each cell has a different darkness basically. And after that I'm blending the color for the borders, like so. And this is the base color. For the roughness, I'm starting with the shade. I'm remapping this and adding some random values and saturating it. And after that, I'm blending the mask back so it has uniform values in the borders. For the normals, I'm using a normal texture I made, and I'm just using a distance blend to flatten the normals at the distance. I think it looks better like that. And this is the end result. And what you can see here is that the lines are very, very straight, which is bothering me. So diagonally you can see visible lines, and every other direction I have very straight lines. So you can fix this by using a noise, for example a Perlin noise with different values for R and G, and adding that value to the UVs, basically distorting it by this noise. So like that, you can see that in the distance there are these little uneven, not straight lines. Thanks for watching. If you like this video, give it a like and subscribe so you don't miss out the next video. Cheers.